Hello and welcome. Today we're talking about water. I've recently implemented a pretty thorough water system in the game. Um, but before we can really talk about water, we got to talk about elevation. So I don't have any visualizations for the elevation yet. I'm hoping soon I'll have visualization like hills and cliffs and that kind of thing. But right now we're just stuck with looking at these debug numbers on top of the cells. Um, and I have debug controls where I can edit the elevation if I want. Um, I also have debug controls that allow me to place water, so I'm going to do that right now. And you can see the water flow out and spread across the ground. Um, there's another debug visualization that lets us see the actual water value of each cell. Um, and this water reserves number, so in the system there's conservation of water. Water's never created or destroyed, but rather it comes down from the clouds onto the ground and then it evaporates back up. So this water reserves represents how much water is trapped in the clouds. And you can see that number is constantly going up because water in other places in the world is evaporating and it's adding to the reserves. So I'm going to turn that visualization back off for now. We might look at it again later. So I'll show you the adding water again. And you can see the water gets darker when it's more dense. And it also respects elevation. So you see the elevation on these cells is 2, which is higher than this base elevation. So the water flows around it. Now if I add water on top of this 2 right here, you can see it flows off of the 2 and then it flows off of the 1s right here, and it creates a little pool. You also notice that while it flows at first because it's all condensed in that single cell that I added it to, it spreads out, but then it eventually stabilizes. Something else you might notice is some of the water's disappearing here. That's due to evaporation. But the places where the water touched is a little bit darker, and that's because the soil there has been saturated by the water. And there's a maximum amount of saturation, and after it reaches that, the ground won't drink any more of the water up. Well, let's add a lot of water and see what it looks like. So you can see the waves kind of splash around as it tries to become stabilized. And if I reduce the elevation here, well, let's do it this way first. Let's put that back and let's add a lot more water here. I want to add enough water so that these 1s here are covered in water, and we can see what happens. So yeah, now the 1s have some water on top of them, the 2 doesn't, and then the area around them is a pretty deep pool at that point. So now if I reduce this by just 1, it'll act like a dam that's overflowing. You can see some of it will flow out to the point where there will still be a pool around here, and these 1s here will probably clear up, and you can see the water's just kind of filling out over the ground here, and the ground's drinking this up, and there's also a little bit of evaporation. And at some point here soon, this will probably stop flowing, because this one, it's not a 0, it's not level with the ground here. So at some point the pool is going to stop overflowing here. I don't know if we want to wait for that though. So something else I've done here is in hindsight I probably should have done this procedurally, but I've hand drawn a lot of these low elevation areas, this sort of spider web of like, I guess, rivers. Then there's this deep lake down here, and you can see the riverbed is still, there's still some water in areas, and it still looks wet in other areas that don't actually have water, and that's because it was raining recently. Rain something else. Oh, here we go. Like I said, there's still a pool here, and it stopped flowing because this one is still blocking it. But if I remove that one, you can see it starts to flow out again. Let's take a look at the debug view again. So this shows the amount of water that is in the process of flowing to each cell and how much water actually exists in each cell. And so this fast evaporation is a debug feature, so you can see what it looks like when it's evaporating quicker, because it's kind of like watching the grass grow if I try to show you what evaporation looks like. But here with the evaporation, it's going 20 times faster than it normally would, and you can see everything's drying up quicker, and so the water dries up first, and then the ground moisture dries up after that. And soon I'll be adding different kinds of plants. So I haven't talked about this in a while, but my vision for the game is to have it be really simulation intensive. I want to simulate a whole ecosystem, and I want everything to be always on, even if the character's not nearby. And then that will act as a context for a survival crafting sort of game. But so the plants are going to draw moisture from the ground and use that to grow and compete with each other and all that kind of stuff. So let's see, what else? I thought this video was going to be longer than it was. This went a lot faster than it took to develop. I think the last thing to show you guys is let's watch how rivers work first, and then at the end we'll look at rain. So let's add a lot of water all over the place. So at first it just kind of spreads out, but after it's sat for a little bit, what you'll be able to see is that it starts to flow in a particular direction, and that's not because it'll start to flow into this lake here, and that's not because the lake itself is drawing the water from long distance. It's just a chain reaction of there being a better place for the water to flow one cell at a time. Like the water in each cell has no knowledge of the water in the whole system. All it knows is the water in the cells directly next to it. So the only reason it would flow in a particular direction is if it's advantageous, if it helps equalize the water one cell at a time. So it takes a second, but for the water to kind of calm down a little bit, but eventually it'll form these rivers around the lower elevation areas, and you can see right now they're kind of flowing back and forth a little bit, but they'll eventually get to flowing in the direction of the lake here, which is pretty cool to see. It's sort of an emergent behavior, and that's a theme that I really want to focus on a lot in the game. And you can see it's starting to flow now. It's not just randomly flowing in every direction. It's sort of flowing towards the lake there. And I want more of that kind of emergent behavior to happen on a regular basis in this game. I also have a debug feature to remove all the water. So we can take a look at how it flows again, because it's just fun to look at. I'll talk a second about the underlying code, because I did some things I think are pretty cool. I haven't read a whole lot on how to do simulation and games and all that, so I'm just sort of learning myself. So the water waves, so first of all, nothing related to water is triggered by a timer event. an ongoing timer event. So the water waves and all the equalizing of the water, that's all triggered by water in a nearby cell being added. So if water's stable in a pool, there's no update logic associated with that whatsoever, and that's for the sake of performance. And so something similar happens with evaporation. When there's water in a cell, there's this evaporation tracker on it, and that has a timer associated with it. Not actually, and I'll talk about that in a second. But after that cell dries up, the evaporation tracker is retired, and it goes back to the pool of evaporation trackers, and it no longer has any logic associated with it. So after water is stable, and after things are dry, there's no logic associated with it. There's not all these timers, and it's not inspecting every cell every so often to see if water update logic needs to happen. And so the way I do the evaporation trackers, I didn't want to have a timer associated with each cell to tell when the evaporation tick should happen. So what I have is I have 300 lists, and the lists each have references to these evaporation trackers, and then it just iterates. It does one list every update, and it iterates through that list. And in this way, you don't actually have timers associated with each cell. You just have, one of the 300 lists might have 10 different evaporation trackers in it, and that happens, once every 300 updates that particular list will get an update. And this is all really complicated. This would probably be better suited to a blog post rather than a YouTube video. I might cut this part out. But so the evaporation tracker objects and the water wave objects are they're not being constantly created and then disposed. Rather, I'm activating them and then retiring them. So they still exist, they're just not being used right now. So you can see there's 4,000 water wave objects, but they don't have any update logic associated with them right now because they're not active. Okay. So anyway, you can see sort of the moisture that's accumulated in the lake bed here. That's pretty cool. That's when the river really starts flowing, is when the ground is fully saturated and it stops drinking the water up. That's what really allows it to just start flowing. But anyway, I've hinted at it a few times. For the last thing for this video, let's watch what it looks like when it rains. And let's so it gets a little dimmer, and you got these little rain particle effects, and then little bits of water are added all over the place. Now let's turn the elevation back on so we can see the river. So right now it's just raining in an area about maybe 3 times as big as the camera can see, and it's centered on the camera. Eventually I want to have like weather patterns with clouds that drop rain in localized areas. I can't have it rain across the entire simulation. That would just kill performance. But rain in a little localized area like this works pretty well. And I know rain is something that people hate in this kind of game. So when it does rain, it's gonna rain a lot really quickly and then be over with. I'm not gonna have it rain for like 30 minutes or an hour at a time like in some other games. So you'll get maybe like 2 minutes of rain or less, maybe once every 30 minutes or an hour or something. Anyway, so we can turn the rain off, and the rain, if we show the water levels, you can see it's actually drawing from the water reserves here. And if the water reserves were to run out, it wouldn't be able to rain anymore, because like I said, there's this conservation of water. So anyway, that's That's water, water flow, evaporation, the beginnings of elevation. Um, that's what I've been working on lately. Elevation is going to affect vision and all that, but I'll show that in a future update. Thanks for watching.